Alright, guys, I hope you all are doing wonderful as you're watching this series on aircraft systems. In this part, we'll be covering landing gears and we'll be studying a lot of different things like what are the different types of landing gears, what are the different loads that a landing gear feels, what is the actual purpose of a landing gear, and a lot of different things which are very, very interesting. And I hope you'll be really enjoying this lecture. And this is not going to be a very long lecture, hopefully, because it is not a very big chapter. So we'll start right away. So these are the different parts that I have posted till now. Firstly, I posted structures, and then there was hydraulics part 1 and part 2. And if you haven't watched these parts, then go ahead and watch them first. They are very, very important for your DGCA exams. And let's continue. So what is the purpose of a landing gear? So landing gear has a lot of different purposes, some of which are mentioned here. The first one is it supports the weight of the aircraft at a height which also gives clearance for engine or propeller. So it makes sense, right? The landing gears, they also provide a height, right? Their first purpose would be what? They provide a height to an aircraft. So why is height important? Because see, the engines they can't be placed on the ground, right? You cannot place it near the ground, right? And or even the propellers, the blades will be touching the ground. You can't place it right there. That's why it is very important for an aircraft to gain a certain height above the ground, right? Where you can place the engines or you can place your propeller, right? That is why landing gears provide a sufficient height or a clearance so that you can put your engines or propellers, right? The second would be it allows for ground maneuvering, right? Without a landing gear, you can't be sliding your aircraft on the ground. You need something, some wheels attached on the bottom surface of the aircraft so that you can maneuver the aircraft on ground, right? The third one would be it absorbs the kinetic energy on landing. The very basic purpose of a landing gear is they absorb the energy and the kinetic energy when the aircraft is coming in for landing, right? So they absorbs this energy and it also helps to decelerate the aircraft after landing. Obviously, you'll be applying brakes, right? So it helps to decelerate the aircraft on landing. What are the different types of layout which a landing gear can be attached to? So there are two types of layout. First is tricycle layout. Second is a tail dragger layout. So in a tricycle layout, as you can see the image here, one nose wheel is here and then two wheels behind it. In a tail dragger, you can see two wheels are ahead and then one is at the rear tail, right? So there are a lot of advantage of a tricycle layout that we will see now. So a tricycle layout has a lot of advantage over the tail dragger style. Why? And what are those advantage? See, the first is that it does not have a risk of tipping over while taxing in tailwind. So in this clip, you can see that this is a tail dragger style, right? There are two wheels ahead and there is one wheel at the rear tail. So this aircraft will be taxiing and we'll see what happens if it taxis in a strong tailwind. So there will be winds coming from here. Okay, now when the aircraft starts to taxi, you see what will happen. See, the aircraft nose can easily touch the ground and the propeller can have a serious damage, right? This can happen in a tail dragger style, which is avoided in a tricycle style. So this is one of the advantage of using a tricycle style landing gear. And then we have it has a better forward visibility for pilots. See, in this will be what your tail dragger style, right? So in a tail dragger style, your visibility will be upwards mostly, right? You won't be able to see the ground much. You'll be looking here because it is tilted upward, right? But in this, the visibility will be what? Forward. You can have a lot of forward visibility. In a tail dragger style, you will be looking upwards most of the time because it is tilted downwards, now. So it will be sitting a little inclined. So this is the second advantage of using a tricycle style. Then the third one is that it gives a level platform. So in this, you can see the platform is very level. See? In this, the platform is not level, it is inclined again, right? So this allows for easy loading. So you can load goods very easily, you can have a comfortable seating. All of those things come with a level platform, right? In this, you won't have a level platform. So there will be a lot of problems while loading cargo in it, right? So these are the three advantages of using a tricycle layout Also, in a tricycle layout, the main wheels absorbs 90% of the weight of landing, while the nose wheel is there for balancing and steering, right? The purpose of a nose wheel is not to actually absorb all of the landing weight, but it is there for balancing and steering, right? You might have seen those landings where the aircraft right before touchdown they flare. So why do they do that? Is to put the weight of the aircraft on the main wheel, because they are designed to absorb the landing weight, 90% of the landing weight, while the remaining is absorbed by the nose wheel, and the nose wheel is not there for actually absorbing the landing weight, it is there for balancing and steering the aircraft, right? Then we have a fixed landing gear. So in a fixed landing gear, as the name suggests, they are fixed. They are not retractable, right? So they'll be always outwards. They'll be always extended, and they won't have any feature to retract them while the aircraft is in cruise or something, right? So they are usually used in trainer aircraft or smaller aircrafts, and they have these following advantages. The first one is simplicity. Obviously, you don't have a retract table landing gears, you don't need any retraction mechanism and all of those things, right? So they're simple, right? Then you have low cost. Obviously, they'll be cheaper because you don't have any retraction mechanism again, right? And then they'll have a reduced maintenance. Yes, again, you don't have more mechanism, more parts, so you don't need much maintenance. So these are the advantages of a fixed landing gear. But the biggest disadvantage is that it produces a lot of drag. We'll study what kind of drag a landing gear produce in POF if I were to make a video on that. But the biggest disadvantage is that it produces a lot of drag. And then there we have three types of fixed landing gear. So the first one is a spring still leg. Second is a rubber cord. Third is Oleo pneumatic. So spring still leg, you can see the diagram here. Rubber cord, you can see it here. Oleo pneumatic, you can see here. We'll study each of them one by one. So in a spring steel leg, as the name suggests, the steel that is used acts as a spring, right? So this that you can see here, this is the spring steel leg. So it is actually a steel rod or a steel stud which acts as a spring. It wiggles a little bit and it absorbs the landing impact. So it is consist of a tapered steel tube with one end attached to fuselage and the other end has an axle with a wheel attached. So it describes itself. The one end is attached here at the fuselage, another one is having an axle on which a wheel is attached. In a rubber cord, again, not much, it just absorbs the landing impact with the help of rubber loops. So there are number of turns of rubber in form of a loop. So this that you are seeing here, this is just rubber in a form of a loop. So this is what a rubber cord is. You don't have to go in any detail. This is all that you have to just remember. And then we have Oleo pneumatic. In a Oleo pneumatic, there is a lot that you have to go in detail in Oleo pneumatic, because these are the landing gears. These are the type of fixed landing gear that we use a lot in even in our aircrafts, in Cessnas that you'll be flying in. And the airliners, you also use this principle. So what is a Oleo pneumatic strut? So Oleo, in my previous video, I also mentioned this. Oleo as what? Oil. Oleo means oil and pneumatic means air. So Oleo pneumatic means oil and air, right? So it consists of two cylinders which are free to slide in each other, which are free to slide inside the other, right? So here also you can see this is the cylinder number one, this is the cylinder number two, and they are able to slide within each other, right? Basically what happens is this cylinder number two, this would be the inner cylinder, the blue one that you're seeing, this is the inner cylinder. This green one that you're seeing is the outer cylinder. So the inner cylinder is able to freely slide in and out of the outer cylinder, right? It is something like this. This would be the green cylinder, the outer cylinder, and the inner cylinder is something like this. So the inner cylinder is able to slide in and out of the outer cylinder, right? And why do I have two cylinder? Because one is filled with hydraulic fluid and the other one is filled with gas. So here you can see this upper cylinder, the outer cylinder is filled with fluid. This is filled with fluid, right? What kind of fluid? This is just your hydraulic fluid, right? And the bottom cylinder, this one is filled with gas. So this is filled with gas, right? I'll have to clean this now. Right. So the outer cylinder is filled with air. hydraulic fluid, the inner cylinder is filled with gas, and these fluid and gases are separated by a separator piston. So this thing that you're seeing here, this is just a separator piston. Its purpose is to separate your hydraulic fluid and air. How does it work? We'll see that now. So in this diagram, you can see that the wheel is moving up and down. Why is it moving up and down? It could be because of some debris on the taxiway. It could be either because of the impact of landing, right? That is causing the wheel to move up and down. And the wheel itself is moving the inner cylinder, right? So you can see this inner cylinder is also moving up and down with the wheel, right? So this thing causes the fluid to move up and down. The air here helps in cushioning the impact of landing, while the fluid is there to dampen the oscillations. So how is it actually dampening? And what is actually dampening? First of all, dampening is what? When you are reducing something in intensity. So if there is a wave and I'm like reducing slowly to nil value, this is what dampening is. So this is exactly what the fluid is doing here, right? Air is there to cushion it, while the fluid is there to dampen it, right? Here again, you can see that the air is there to support the weight of the aircraft and to cushion the bumps on landing or on taxi, right? And the fluid is there to dampen the oscillation, right? How does it actually dampens the oscillation? That we'll see now. So we have something known as a flutter valve. So a flutter valve is here. You can see a zoomed in version here. So a flutter valve is nothing. It has a plate which is fixed and a plate which is moving. So this plate that I'm drawing is a moving plate, right? So a moving plate has a single hole in the center, right? And the other plate that is a fixed plate is having a lot of holes, one in the center and a lot of holes in the sides, right? So we have two plates. One is a moving plate which is drawn below, and another one is a fixed plate which is drawn above. So in this also, in this diagram, you can also see that this silver plate that you're seeing here on top, this is a fixed plate, while the red plate that you're seeing on the bottom, this is a moving plate. So, what happens is, see, first tell me one thing. If I move the wheel downwards, right? If I move the wheel down, what will happen to the cylinder, the inner cylinder? What will happen to this? This is the inner cylinder. What will happen to this? Will it move up? Will it move down? Yes, it will move downwards. Why? See, this is our wheel and this is our inner cylinder attached directly to the wheel, and there is a outer cylinder attached somewhere here, right? So if it's directly attached to the wheel, so if the wheel moves downwards, the whole inner cylinder will also move down, right? Understood? Now tell me the second thing. Second thing is, tell me what will happen to the fluid. Will it move upwards? Will it move downwards? Yes, it will move upwards, right? Why? See, this is our wheel. It is moving downwards, which is moving the whole inner cylinder downwards, right? And the outer cylinder is somewhere here, right? Now the fluid is here in this cylinder. So since the whole inner cylinder is moving downwards, but due to inertia, the fluid is not attached directly with the cylinder, right? The fluid is here and it is not attached with the cylinder, it is not sticked with the cylinder. So, what will happen with respect to this inner cylinder? With respect to the inner cylinder, the whole fluid will start to move upwards, right? Since the whole cylinder assembly is moving down, the fluid will start to move up, right? So this you need to understand. If the wheel is moving down, the fluid will move up. If the wheel is moving up, the fluid will move down. Understood? This you need to know in order to understand how it all actually works. Now it will all make sense. See, this is our zoomed in version of the flutter valve. Here you can see the bottom piston is a free floating piston which will move with the fluid. So if the fluid is moving upwards, the bottom piston will, the bottom plate will move upwards. If the fluid is moving downwards, the bottom plate will move downwards with the fluid, right? And the top plate that you're seeing, this one, this is a fixed plate, right? So it has multiple holes and a one hole in the center. So now you'll see what and how it all works. See, so now in this case, you can see the wheel is moving downwards, which is causing the whole cylinder to move down, and the flutter valve is moving up. Since the flutter valve is moving upwards, you can see the free floating piston or the free floating plate is also moving upwards, which blocked these holes, right? And the fluid is moving through the center hole only, right? And since the fluid is moving through the center hole, the rate of flow of fluid will be lesser. But in the second scenario, in this case, the wheel is moving upwards, which causes the cylinder to move up, but the fluid to move down. And this caused the free floating piston to move downwards, opening all of these holes, and hence the fluid is able to flow freely, which is increasing the rate of flow, and the rate of flow has increased, hence there will be again dampening, right? So this is how it all actually works. Then there is something called as a torque link. So torque link is nothing but a link that connects the outer cylinder with the inner cylinder. So what happens is the inner cylinder is allowed to move freely in and out of the outer cylinder, right? It is free to move up and down, but in order to avoid any rotary motion, any twisting motion, there is an installation of a torque link. So inner cylinder is free to move up and down, but the rotary motion is prevented by the use of a torque link. So torque link is what? It connects outer cylinder with the inner cylinder, hence absorbs the torsion or the twisting load during the ground maneuvering. Then we have the methods of attaching wheels. So they are pretty self-explanatory. First is fork. It looks like a fork. Then we have half fork, cantilever, dual wing, multi wheel. So you just have to go through the images. They might ask you image-based questions, so just go through them once, have a look, and remember their names with their pictures. All right. Then we have loads on landing gear. So there are a variety of loads that a landing gear feel during its service. Now, the first one is compressive load or compression. So compression is what? Compression is something that shortens the structural member. This we have studied in structural. If you haven't watched the structures ka chapter, then watch it. So compression is something that shortens the structural member. So when do the landing gear feel compressive load? Of course, when the aircraft lands, right? So when the aircraft comes in for a landing, the landing gear compresses. So that is when the aircraft feel compressive load. That is during landing, and when the aircraft is stationary on ground. So even when the aircraft is just standing on the ground, then also the landing gears will be compressed, right? So this is something that is felt when the aircraft lands and also when the aircraft just sitting there on ground, right? And it is taken by strut. Again, this we have studied in structures that compressive loads are always taken by struts. And then we have rearward bending. So when do you think the aircraft landing gear will be bended rearward? It would be obviously during pushback and when the aircraft is trying to brake. So any rearward bending is what? When the landing gear is being pushed backwards, right? So this the aircraft will feel when you apply brakes, obviously. And also when the aircraft is being pushed back. Pushback is what? When a towing truck comes in and it pushes the aircraft, it attaches to the wheel and then it would be pushed backwards, right? So that is when the aircraft feels rearward bending, and it is taken by what? Drag strut. So any rearward bending would be taken by drag strut, any compressive load will be taken by a strut. And then we have side loads. So side loads would be during crosswind landings and they are also taken by side strut. So it is just a name. Drag strut is for rearward bending and side struts are there for side loads. Side loads would be felt during a crosswind landing. If you have seen any video of a crosswind landing, then you might have seen that the aircraft comes in not aligned with the runway. So the aircraft nose might be pointing somewhere else and they come in like a crab. So that is when the aircraft feels rear side loads, right? And it is taken by side strut. Then we have turning. So how does an aircraft turn on ground? So there are two different methods for turning the aircraft. These methods are differential braking and then we have hydraulically operated nose wheel. So differential braking is nothing, it's just you have an aircraft like this and for example there is a wheel over here and another wheel maybe somewhere here. So what you do is you apply brake on one wheel. For example, you apply brake on this particular wheel. So what will happen? The aircraft was moving forward and now you applied brake here. So the aircraft will have a turning motion, right? It will turn to the left hand side. And same will happen if you apply the opposite side of brake. If you have one wheel somewhere here, another wheel here, if you apply brake on this wheel, then as the aircraft was moving like this, you applied this brake, so the aircraft will turn to the right hand side, right? So this is what differential braking is. And for a aircraft to work properly with a differential braking system, it must have a castering nose wheel. What is a castering nose wheel that we'll see? The second type would be hydraulically operated nose wheel. So it is just a nose wheel that is actually moved with the help of hydraulics. So this is another method of turning the aircraft. We'll see what a casting nose wheel is. So a caster wheel or a casting nose wheel is what is the ability of the nose wheel to turn to either side as a result of differential braking and return back to its center position when the forces are removed. So you might have seen these kind of wheels on your office chairs. These wheels are not operated by anyone, right? They move by themselves in a certain direction, and this is exactly what is in your nose wheel. So what happens is whenever you use differential braking, for example, you have a wheel here, and you apply this particular side of brakes, the aircraft will tend to turn to this direction, right? So the nose wheel will automatically turn itself in this particular direction so that the aircraft can move in this direction. The nozzle is not hydraulically operated or electrically driven or anything. It does not have any machinery, it just moves by itself. That is what a caster wheel is. Even in your office chairs, these wheels turn by themselves in a certain direction to allow ease of movement, right? So whenever you're using differential braking, you'll mostly have what caster wheels attached to your nose wheel. And yeah, since a caster wheel is free to move in any direction, right? So it could happen that sometimes the wheel is like this and the aircraft has taken off. Now, since it is a retractable landing gear, the landing gear will what? It will retract and will come back inside. But if the wheel is twisted like this, it is like this, right? It is not aligned with the fuselage. So there is not enough space in the what do you call it, your undercarriage, your nose wheel undercarriage, that it can fit a wheel that is twisted, right? So this can cause some serious damage if the wheel is not aligned in a certain direction, right? This wheel cannot be retracted, right? It cannot be retracted like this because it is twisted, right? So, but the caster wheel must be moved to center before retraction of landing gear or serious damage to the airframe. Exactly, this could happen, right? And nose wheel self-centering is done by either hydraulic or a cam system which is spring loaded. So this you can just keep in your head that there is a cam system which is spring loaded, or you can either use your hydraulics to center the wheel. The purpose of centering it is because there is not enough space in your undercarriage so that it can fit a wheel that is twisted, right? So the wheel has to be moved to the center and then only it can be retracted. There was one incident that had happened. In this, you
At
can see
LAX, the one they want to use for emergency landings if they
this
can. And
particular
here it comes
aircraft. You
in
can
now,
see the
this
wheel.
JetBlue flight
It is
292
not aligned with the
with that
fuselage,
front nose
so
gear
it was not
pointed
able to
sideways.
retract, and the aircraft had to land like that. Hold the nose.
Seen a lot of smoke, but so far it's still intact. The landing gear.
He's now slowing down as best he can.
End of the runway.
Mighty strong landing gear here. That's the tires burning out there.
All right.
Best of all possible scenarios, it did not collapse. The chin gear, or the chin of that aircraft did not skid down the runway. It has come to a complete stop. They will now.
That you saw, and the landing gear was not in the centered position, so it was not able to retract, and the aircraft had to make an emergency landing with the landing gear or the nose wheel not aligned with the center line, right? And then we have something known as a bypass pin. a bypass pin is inserted which disconnects the nose wheel from the steering system, allowing for a ground towing. So you might have seen these kind of pins that are attached and says remove before flight. These kind of pins are what bypass pin. So what they do is they isolate the nose wheel from the system, from the turning or the steering system, right? So that the ground staff can just attach their vehicles and they can easily move the nose wheel in whichever direction they want, right? So these pins have to be removed before flight, or else the pilot won't have any control over the nose wheel. So this is for a hydraulically operated nose wheel, right? For a caster wheel, you don't need such thing because caster wheel moves by itself, so you don't need any of these pins and all. And yeah, as it mentions, it should be removed before flight. Then we have something called a shimmy. Shimmy is a unstable, rapid sinusoidal oscillation or vibration of the wheel. You can see this video over here. You will know what a shimmy is. So that you saw was a nose wheel that was vibrating violently, right? Or was having a sinusoidal oscillation that you can call it. That was something known as shimmy. So shimmy can be due to either a broken or a damaged torque link. Torque link that we saw was that was connecting outer and inner cylinder, right? So it could be either because the torque link has broken or it is damaged, or it could be either because of uneven tire pressure. So the tire pressure on either wheel are not correct. It is uneven. It can also be due to wear in the wheel bearing, right? So this is what a shimmy is, and these are the probable causes. Then shimmy can be prevented by use of the following. We have first a shimmy damper. So this thing that you're seeing here, this is a shimmy damper, and it again a damper, so it reduces the oscillations slowly and then it comes to a stop. So this is a shimmy damper which is fitted in the nose wheel to avoid shimmy, or we can use double tire. Double tire is just using two tires in a pair. This also reduces the shimmy. Also, with a proper maintenance, you are properly maintaining your wheel bearings, you're maintaining your tire pressure, you're maintaining your torque link, so that will also reduce the chances or of shimmy, right? Alright, so next we have is indicators. So what are these indicators? There are certain indicators in the cockpit that shows the position of the landing gear, right? Because pilots cannot just look through the window and then they can tell ki if the landing gear is down or no, right? So that is why we have indicators in the cockpit which tells us whether the landing gear is down or locked or what kind of position is it in. So here you can see in this image we have a left gear indicator, we have a nose gear indicator, and we have a right gear indicator. And these buttons can be either green or red. So if you're seeing three green lights like this, and this, all three lights are green, which means the landing gear is down and it is locked. So this is what three green lights mean. If you are seeing three red light, it means that the landing gear is not locked in the selected position. It can be either you have selected the landing gear in the up position and it is not locked there, right? And if you have selected down position, so it means that it is not locked in the down position. So three red light means the landing gear is not locked in whatever position you have selected. And if you're seeing no lights, if all the lights are off, it means that the landing gear is up and locked, right? Because most of the time in the cruise, you'll have your landing gear as up and locked. That is why there are no lights in the cockpit, so it will avoid any kind of distraction, right? And it is not at all important, right? The most unimportant position would be up and locked, right? That is why there is no light for that. And these indicators get their input from micro switches or proximity sensors. So you can just keep this on your head that there are micro switches or proximity sensors that gives this input to the your indicators, right? So they gives this sensor input to the indicators and then they show it in the cockpit. Then there are also mechanical indicators. If in case the light indicators fuses or there is some electrical failure, so you always have a backup. That is the mechanical indicator. Some aircraft are fitted with this, some are not. So what are these? They are actually located on the wings. So what will happen if when the gear is down and locked, In this particular scenario, these will pop out. So you can see a button kind of thing will pop out on the wings. And pilots won't be able to see from the cockpit, obviously. So they might have to ask their flight attendant to take a look out of the window through the fuselage, and then she can tell if the switch is popped out, which means the landing gear is down and locked. Then we have some points to remember. So the first one is the actuator which moves the landing gear up and down is a double acting unbalanced piston. So this we have already studied in hydraulics chapter that the piston which was moving landing gear up and down was a double acting unbalanced piston. Why was it called double acting? Because it had hydraulic fluid on both the side. So both the sides were controlled by hydraulic fluid, and unbalanced means that the piston had only one side attached with a piston rod and the other side was free. So we had multiple forces because of more area, less area. This we all studied, right? If you remember, if you have already seen the hydraulics video, then you must have a good understanding of this, right? Then the second one is the actuator which locks the gear up lock and the down lock is a single acting piston, right? Single acting was what? One side was controlled by hydraulic fluid and the other side had what? Spring, right? So that is why it was locked with a spring, if you remember. So this is our single acting piston, which is used in uplocks and downlocks. And the lock, which is used in the uplocks and downlock, is also called as a geometric lock. This you just need to remember the name, geometric lock. It is something that is used in the uplocks and downlocks of a landing gear, right? So these points, just make a note of them. They are important for your exam. Then we have inadvertent moving of landing gear. So that is what accidental moving of landing gear. You did not want to move the landing gear lever, but you somehow by mistake moved it. So there are certain protection to avoid that to happen ever. So what are these protection? So when the aircraft is on ground, inadvertent movement of a landing gear is prevented by. So on a ground, if the aircraft is standing on the ground, would you think a pilot ever want to put the landing gear in the up position? Never, right? Because the aircraft would collapse. So the pilots never would do that. But by mistake, if someone accidentally moved it, so it is avoided to ever happen. How is it done? So firstly, there is a mechanical lock. Mechanical lock is by physically blocking the gear lever with a lock lifted by a solenoid, right? So you might have seen these landing gear lever in the cockpit. So it is like this, and it is shaped like a landing gear. So this is a landing gear lever in a cockpit. So there is a mechanical lock somewhere here. They place a lock, a particular actual mechanical lock here. So the landing gear cannot be physically lifted upwards when it is on ground, and it is locked with a solenoid. So there is a solenoid here, and it locks it, right? And when the aircraft takes off, the solenoid is then automatically it backs off, and it lets the lever to be lifted upwards when needed, right? In case the solenoid fails, then the pilots can use their hands to mechanically lift this lock and can lift the landing gear upwards. All right, so this was the first protection. The second protection is a ground locking pin. So a ground locking pin is fitted in the landing gear, which has to be removed before every flight, and it is stored in flight as a position where the in cockpit it is visible to the crew. So basically, there is a pin that is inserted in the landing gear. It also avoids it from being retracted. And before every flight, this pin has to be removed, or else the landing gear will not be able to retract after the aircraft has taken off. So that is why it is very important to remove this pin, and it is stored in cockpit in a position where the pilots can physically verify that the pin has been removed. So you'll place it, for example, here, and the pilots can visually inspect, yes, the pin is in the cockpit, it means it has been removed. Then there is emergency lowering of landing gear. So in case the hydraulic systems fails to put the gear down. So some aircrafts have a free fall mechanism. What happens is that the up locks, the locks that are keeping the gear in the retracted position, are released. So these up locks that are keeping the landing gear in up position are released electrically, and then these gears they literally just fall down due to gravity, and then they do a free fall and they are now in extended position. So up locks are removed electrically and the gear free falls under gravity. Some aircraft might have a backup system for such failure. They might have a separate air-driven pump air driven pump would be here and it is powering the system. It might also have a hand operated system. So in the cockpit, you have a hand operated lever which you can lift up and down. Some might have a hydraulic accumulator, some might have an electrical system. So it varies according to the aircraft type. Alright, that's all that there is in landing gears. I hope you watched the video till end. And if you made it this far, then definitely you're gonna ace your exam for sure. I hope you are making your own notes and you're revising them continuously. And at the end, we might also do some question practice that will definitely help you with their exam. And that's all for this video. I hope you liked it. All right, bye bye, enjoy.